Your database just refused to save a value. The error message says, check constraint violation. The number looks perfectly fine to you. It's a number. It's in the right column. Why is the database rejecting it? Most developers treat this as an obstacle. Find the constraint, disable it, move on. That instinct is exactly backwards. The database didn't fail. It worked. It stopped something from entering your system. That would have caused a problem you'd have spent days tracking down. The question isn't why the database rejected the number. It's what would have happened if it hadn't. A value constraint is a rule that every value in a column must satisfy before it is allowed to exist in the table. Not a suggestion, not a reminder in a comment. A hard rule, enforced by the database engine itself, applied to every single write, no exceptions. The most common forms are simple enough to state in one sentence each. A range constraint says, this value must fall between a minimum and a maximum. An account balance must be 0 or greater. A percentage must be between 0 and 100. A product rating must be between 1 and 5. A set constraint says, this value must be one of an approved list. An order status must be pending, confirmed, shipped, or delivered. A priority must be low, medium, or high. A country code must be a valid ISO code. A format constraint says, this value must match a specific pattern. A phone number must contain only digits. A postal code must match the format for its country. An identifier must follow a defined structure. Each of these sounds obvious. None of them are enforced automatically. You have to define them. And in most production databases, most of them are absent. Here is what the absence of a range constraint looks like in practice. In 2019, an e-commerce company ran a promotional campaign offering a 20% discount on selected products. A developer built the discount system with a discount column stored as a decimal, the right type. No value constraint was applied. During the campaign, a data entry error in the promotions tool submitted a discount value of 120, meaning 120%. The database accepted it. The application applied the discount. Customers were being charged negative amounts. The store was effectively paying them to take products. The error ran for 4 hours before a finance alert caught it. The refunds and reconciliation took 3 days. A single check constraint, discount must be between 0 and 100, would have rejected the 120 value at the moment of insertion. The error would have surfaced immediately in the promotions tool as a validation failure. No orders would have been affected. No refunds, no reconciliation. The decimal type was correct. The business rule was missing. And the gap between those two things was 4 hours of customers being paid to shop. Let me show you the set constraint failure, because it's subtler and more common. A logistics company tracked shipment state with a status column. The allowed values were pending, collected, in transit, delivered, failed. No set constraint enforced this. The column was a varchar. It accepted any text. Over 3 years, 12 developers had written code that inserted into this table. Most used the correct values. 3 used variations, in transit, with a space instead of underscore, delivered with a capital D, complete instead of delivered. None of these insertions threw an error. All of them were quietly stored. When the company built a reporting dashboard that counted shipments by status, the delivered count was wrong. Some deliveries were under-delivered, some under-complete. The dashboard showed lower delivery rates than reality. The operations team spent weeks investigating a performance problem that didn't exist. A set constraint, status must be one of this exact list, would have rejected in transit, delivered, and complete on arrival. Every developer who used a wrong value would have received an immediate error. The variations would never have entered the table. The dashboard would have been correct from the first day. Now here's the part that makes value constraints genuinely powerful and genuinely different from application-level validation. Application validation runs in your code. It checks values before they reach the database, and it works for every write that goes through your application. But not every write goes through your application. A developer running a data fix directly in the database bypasses it. A migration script bypasses it. An analytics tool with direct database access bypasses it. A third-party integration that writes via a direct connection bypasses it. A new microservice that someone built without knowing about the validation rules bypasses it. Every one of these paths is a gap in your application-level validation. And in most production systems, all of these paths exist and are used regularly. Value constraints at the database level have no gaps. They apply to every write, from every source, through every path. There is no way to insert a discount of 120 if the constraint says otherwise. There is no way to insert delivered with a capital D if the constraint says otherwise. The rule is in the table. The table enforces it. No code can circumvent it. This is why application validation and database constraints are not alternatives. They are layers. Application validation gives the user a friendly error message. Database constraints are the guarantee. The objection developers raise most often is flexibility. Value constraints make it harder to change business rules. If the allowed discount range changes, you have to migrate the constraint. If a new status value is added, you have to alter the table. This feels like extra work. It is extra work. It is also the right amount of work. When a business rule changes, when the discount range or the status vocabulary changes, every system that depends on that rule needs to know about it. The application code needs updating. The API documentation needs updating. The reporting queries need updating. The data dictionary needs updating. Updating the database constraint is one more item on that list. It is also the item that prevents old values from continuing to enter the table through every path that hasn't been updated yet. Without the constraint, changing a business rule means trusting that every developer, every integration, every script has been updated. Trust is not enforcement. The constraint is enforcement. 3 things to do when you design a column that will hold a constrained value. First, write the constraint before you write the application validation. The constraint is the rule. The application validation is the user experience. Decide the rule first, then decide how to communicate it. Second, name your constraints explicitly. A constraint called CK discount range is findable. A constraint called constraint 1 is a mystery. When the violation appears in an error log, a named constraint tells the developer exactly which rule was broken. An unnamed one tells them nothing. Third, review your existing tables for columns that have implicit range or set rules, with no constraint enforcing them. Every column with a name like status, type, priority, percentage, rating, score, almost certainly has a valid range or an approved set of values that is currently held only in application code, documentation, or institutional memory. Each of those columns is a gap. The gap is where the discount of 120 enters. The gap is where delivered with a capital D accumulates. The gap is where the business rule lives, right up until the moment something violates it, and nobody can explain where the bad value came from. Your database didn't reject that number to make your life harder. It rejected it because you told it to. Or, more likely, someone told it to, a long time ago, because they had seen what happens when the rule isn't there. The constraint violation in your error log is the cheapest possible version of the problem it prevented. A row that failed to insert. An error you can see, in the tool you're already using, at the exact moment the bad value tried to enter. The alternative is a discount of 120, running silently for 4 hours, while the store pays customers to take its products, and no error is thrown anywhere.